You should do that. Okay, there's this. Turn to your workbook, please.
I didn't understand.
Okay.
So when Mr. Seville wanted us to add POV, we have to write all the numbers on the number line, and can we just put all the numbers?
You do not have to put all the numbers on the number line.
Yeah.
So we just have to put a couple numbers by our answer. Meaning, if I am graphing in number 5, I could see that you had -4 over here, and maybe you have 0, and maybe you even put -8. Or if you wanted to put -5 right by it, and -3, and you only had those numbers, okay? I would be okay if I have 2 or 3 numbers, greater or equal, like that.
Well, he taught us just putting 1 on.
Yep.
Is that okay just for this time?
It is. You do not have to go back and change that.
Okay, good.
Do you have anything with these in your handy in?
Oh, my book.
Okay. So I usually like to have my students put at least 2 or 3 one number on each side so that they really know where those numbers are. No problem. Okay. So, any other major questions besides 25 and 26? Okay. So we're going to look at 25 and 26. Jack, do you have something else?
Like the 27 and like the 28 and 29 like that.
Okay. Yep.
Actually, this is number 5. Write a verbal phrase to describe an inequality.
You didn't have to grab
Oh yeah, you didn't have to grab. My fault.
Oh,
It should have been F is greater or equal to -4.
Or he said all numbers greater than or equal to -4.
I would love that too. All numbers greater or equal to -4. What's that? Yes, that is going to work. Okay? So we want to take a look right now at number 25 and 26. 25 says using the following information for both of these questions, right? So we want to make sure we're using it for both of them. And as we look at that, they are telling us that we want to write and solve an inequality. You're trying to run 5 miles. So use the following information. You're trying to run 5 miles in less than 30 minutes. You run the first mile in 5 minutes. So, first mile, 5 minutes, right? Plus the second mile, you run in 7 minutes. The third mile, you run in 8 minutes. The fourth mile, you run in 6 minutes. And the question is, we got to run the last mile, right? X. And it has to be less or equal to what? 30 minutes, right? So we're going to add all these together. We have 5 plus 7 plus 8 plus 6. So we are adding all of those. How much does that come out to be? 26. Plus X is less or equal to 30. So this is writing it. Now when we solve that, we're going to subtract 26 from both sides. And X will be less or equal to 4. Could he run a 4-minute mile and get less than 30 minutes?
That's impossible.
He's really fast. It is. He could. Could he run? And so it says, what are all of his possibilities? Can he run a negative time? Thanks. Take care. I'll put the notes up.
That's
So when it says graph the range of the times of the last mile, the lowest we can go is really he can't go 0, right?
Yeah, he teleported.
So he could go from 4 to 3 to 2, but we really have to stop here, right? This isn't going to be an arrow going down because you can't run, hey, I just ran a -4 on the mile. I ran in a -4 minutes. And you can't go backwards, right? So we have to stop here. And really, can we have 0? I mean, how can you run in no time? And really, it's probably not even that realistic that you have some of these times, right? But as far as graphing it and the possibilities mathematically, that's what we're looking at. Yeah, Whitney.
But it says less than. It's only less than or equal to 4. So it can't be 30 minutes because it has to be less
Oh, good. It has to be just less. All the way less.
than. Okay.
So we can't have 4, open circle. And it's going to be an open circle down here because you really can't have 0. So if you had it with an arrow, don't mark it wrong, but you got to make sure.
1 mile in 30 minutes?
I can't.
That's faster than the first world record.
So it says, write a verbal sentence that describes the compound inequality. These are tougher. So when we take a look at number 27, I always want you to read the variable first, okay? So we want to think variable first. If I'm thinking of the variable first, we would read this as x is greater than -3. Notice I put it open towards the x, just like it was. And x is less than 4. Okay? When we read this, next year when you get into algebra, we do quite a bit with these compound inequalities. Okay? We just finished it in the first month of school. We did this in Algebra 1, where you have compound inequalities that you're solving. When you look at this equation, you need to know that you read the variable first, and we read this that x is greater than -3 and less than 4. So, yes, Kyler.
I wrote all numbers that are greater than -3 but less than 4.
Yes. So when they ask us to write the verbal sentence, this is what we're thinking about. The numbers have to be in between those two. So you could say all numbers greater than -3 less than 4. What could we say about this one? The numbers are going to be between 8 and 13. Do they include 8 and 13?
Yes.
Yes, because of the equals. This one is going to be greater than 0 and less or equal to 7. But when you think of writing it also, this is kind of how you could have written that inequality out. These two mean the same thing, okay? So, because I wasn't here, we are not going to hand this in. But next, what I do want to get from you is you should have had at this point the C5, and I really want to see your C4 showing the inverse operation. So those 2 papers, we are going to cut those out, and you want to make sure that on the top of both the 3-1 and the top of the 3-2 that you have your name on those papers, and then we can hand them in today. Okay?
C5, C4,
So it's the large 3-1 and 3-2 on the top. I don't think I need the 1 and 2 because we did those extra practice worksheets that were like those. So I just need the 3 and 4. We're not going to do 5 at this point.
3, 4, but not 5.
Not 5 because I want to make sure if anyone has lots of questions that you read. Okay? So, C1. There is something special that happens, and did you guys do last year? You might not, you just graphed them, right? Was my understanding from last year. So I want you to multiply on both sides, these 2 numbers that are here in your notes. I want you to multiply them both by a positive 2. If I multiply them both by a positive 2, what's my new inequality going to be? It's going to be what? -4 less than 8. True? True. Now go back to this original one, and this time I'll change color for you. We're going to multiply them both by -2.
But if you
Just multiply the original one by -2. Just write -2 times 2 times -2. Just multiply. Take this -2 times this -2. That's going to give us 4.
Is less than -8.
True? False. Okay? I want you to go back to this original problem. And I want you, this time we'll go change color again. We're going to divide everything by 2. Divide by 2. Divide by 2. Here we multiply by -2, and here we multiply by 2. So if I divide by just 2, I'm going to end up with -1. less than 2. True.
I'm confused how it's true.
I don't understand.
You don't know that -4 is less than -8. If I look at a number line, here's 0, here's -4. Isn't that a true statement that -4 is way less than than 8?
Yeah.
And now if I look at this one and I say, okay, here's -8, and here's 0, and here's 4, and I say 4 is less than -8, no, it's not. It's false. It's way greater than, okay? We're just asked, right? It says choose 2 different integers and tell if it's true. So now we want to divide this time by, let's put in another color, divide by -2. So go back to the original one, divide it by -2. That gives us 1 and less than -2. That is also a false statement, right? Because if I'm looking at my numbers here, this was -1, this was 0, this was 2. This is a true statement. This statement is false. And the reason we are looking at this is because when we start solving with multiplication and division, different than addition and subtraction, you will have a negative number sometimes times your variable as the coefficient. You will sometimes have a negative number that you're dividing by. And anytime you do that, that has to be like red flag. Oh my gosh, I have to change the inequality. And so that is the key thing that we're going to talk about here. So solving inequalities are one important difference. Look what happens when we take this original problem, 3 greater than 1. We multiply both sides by -3. It actually switches it around. Here, we knew 3 was greater than 1. But when we multiplied it, this is our new statement, right? -3 is less than -1. And if we keep everything in the same order, what has to happen is that this inequality was originally a greater, has to flip to the opposite, the inverse. So they always say you reverse the direction of the inequality anytime you multiply or divide by a negative. So, turn to that next page, 22 in your notes. And it says, okay, what happens if I multiply by 1/6 on both sides to solve this? And a lot of you, what would you have done if you saw 6x less than 14? Would you just have divided by 6 on both sides? I would too. I'd just put divide by 6. But no, dividing by 6 is the same as multiplying by 1/6. And the question is, should we change our inequality? No, we multiply by a positive number. But if we multiply by a negative, and we started with this was less than, this has to switch to a greater than. Okay? So the key thing is multiplying or dividing by this negative, we have to switch the sign. So when we look at this problem, and it says a negative 1/4 times m. The inverse of multiplying by a negative 1/4, sometimes people think I should divide. We don't want to divide. We want to multiply by the reciprocal. So we're going to put negative 1/4 m. What is the reciprocal of negative 1/4? Negative 4/1. That means on this side, we're going to keep our inequality at this point, and we're going to put 6 times negative 4. So we multiply both sides by negative 4. We should switch the inequality. Because it was greater or equal, we're now going to make it less or equal. And we get negative 24. Now, I will always have people say to me, well, how do I know if I did it right? Okay, so let's think of what the graph of this looks like. Here's negative 24. Here's like negative 30, right? My graph right now is looking like this. We think negative 30 should make it true, but if I would have picked 0, it should make it false, right? And instead of picking negative 30, let's pick a multiple of 4. What's a multiple of 4 that is less than negative 24? Like negative 28, right? 28, that makes sense? So let's plug in the original problem. So if we're going to do a check, okay, if I take negative 1/4, and it's really important for the checks with the multiply divide, and I take it times a negative 28. The question is that going to be greater or equal to 6? Well, what happens when 4 goes into 28? How many times? 7. And negative times a negative? Isn't 7 greater or equal to 6?
Yeah.
Yes. So this arrow is telling us we graphed it the right way and we changed this inequality. Because if we would plug in 0, it would make it a false statement, right? 0 is never going to be greater or equal to 6, right? But when I multiply that by a negative. So the other property is with division, and it says if you divide both sides by 7, should we, if we do a positive number, should we ever switch it? No. Only if we divide negative 2x and we divide this by negative 2 on both sides, then this switches to the opposite. So I kind of want to get to where we're working on the problems with you, but dividing, if you have a negative or multiplying by a negative, you have to switch the inequality. Okay? Now, if we look at this one, first off, it's not even written in the right form that we like, but what do I need to do to find out what 1x? We're going to, Jaden, divide both sides by?
Negative 9.
Negative 9. So I'm going to put 45 divided by negative 9. I have to keep this at this point, negative 9x divided by negative 9. These 9s are going to cancel, makes it 1. And I have x, and since it was, here we had the negative 5. Since it was open to the negative 5, I have to switch that. So when we talk about switching our inequality, we are talking about that we started with the less than, and we are now having it as, if we are looking at this one, it was a greater, it's now less. We have to rewrite our answer, because remember, we want the variable first. So tell me, Abby, how should I write it? X is greater than negative 5. And my hint when you do these questions in your homework, I would, instead of doing it after, I would right away put the negative, put the variable first, put it like this, and do your 45. So that then you don't have to worry about rewriting it at the end. Because some of you, if you graph it like this, you'll have your arrow going to the left, which is wrong. Because it's really greater than negative 5, not less. Okay? All right. So let's just do these 4. And then I kind of would like to get into your homework. So let's do these 4. And then I want to get into your homework instead of taking all of the extra ones. So there's 4 questions. They're all multiply or divide. Try them right now. Show your work. Opposite of dividing by 7 is to times by 7. Okay? That's my work. You're going to give me the solution, and then I want you to graph the first one here. We'll do the second one down below here. We'll do the third one here. And we'll do the fourth one on the last graph. Okay? You've done the first one. Try number 2. In that first one, opposite of dividing by 7, we said we're multiplying, so we showed this times 7 on both sides. 7 times 7 gives us 49. These ends on this case are going to cancel, or the 7s cancel, and our graph that we are looking at is n is greater than 49. So when I look at my number line here, I should have 49, maybe 50, and 48. So just so that you know where your positive and negative which way. Open or close at 49? Open. Arrow going to the right. Question 2. As I look at the question, Emily, I have negative 1/5 times y. What do I want to multiply by on both sides? I want to take negative 5. So I'm going to put negative 5. I'm taking that times this negative 1/5 y. I have less or equal to 20, and I'm taking that times negative 5. The negative times a negative gives me positive y. Those cancel, right? 20 times negative 5 is going to give me, Jeff? So y is what? How much? 20 times negative 5? Careful. Times 5. Not times 4. Negative 100. We would say y is what? Greater or equal. Why greater or equal? Because we multiplied negative and negative, we have to switch it, right? It was less, has to be greater. If we think of a number greater or equal to 100, if I plug in 0, does it make this true? If I plug in 0 for y, does it make it true? Yeah. So 0 is greater or equal to negative 100, right? We could have tried negative 50, or we could have tried any number bigger than that, okay? Then you're going to graph it down below. Grace, we're looking at this equation. I would like you to rewrite it so we see that written like this first. Negative 2x, how could I do it? Should I have it open towards the 2x or close? Open. So negative 2x greater than 26. So I like to put my equation so I have my variable first right away. Do you have to do it that way? No. What are you going to do next, Jack, next to her?
Divide 26 by negative 2.
And I'm actually going to do the division on both sides of my inequality. So I get this negative 13. Kylie, what am I going to start as I'm writing? X is
Less than.
less than. And again, because this negative, we have to switch, right? We have to switch it, okay? Then you're going to graph them down below for me. Last one as I'm looking. What should I do first, Maria?
Divide by 8.
Divide by 8. When I do that division by 8, Lucas, I'm going to have t is
Less than 8.
less than 8. Has everyone had a chance to graph them before I put up those answers? Try graphing these. Graph them each time. I will even sometimes have, like in this one, if I have negative 13, I might put 0 and I might put negative 26. Just so that I can see that you know where 0 is, right? So put a couple of numbers when you're doing it, because the solution here is like this one. Whereas when it's greater or equal to negative 100, I might put, oh, here's negative 100, and it's a closed circle, and here's 0, and here's negative 200, right? Just so I can kind of see that you understand how that number line is. Well, when I'm looking at 8, I might be okay with 10 and 6, right? Or something like that. Less than 8. Questions as you looked at the graphs? Let's go to the one-story problem, and then let's go to your homework. This is the one-story problem. Yep. Last one is the story problem, and then I really want to get your homework started. So it says, you want to buy a share of stock in a company. Each share of the stock is $12.50 each, and you can spend no more than $3.25. Can you spend $3.50? No. Can you spend $300? Yeah. Could you spend $100? You can spend $50, right? You could spend $5. You cannot spend $500, right? You can spend no more than $325. So, meaning, can we spend $325? Yes. So when we are looking at this, what are we going to be filling in for our inequality? Please put down, if we are looking at this, we're going to have the cost per share. That's how much each share costs us. And we're looking at how many we can buy. the number of shares, right? So when you do a verbal model, you have to relate it to this story. And we can't buy 325. We have to buy less or equal than my 325, the amount of money we can spend, right? We can spend no more than 325. So how does it look algebraically? This is when you write it out. How much did our share cost? The stock? $12.50.
That is a cheap stock.
It is a pretty cheap stock, but you never know. It could start cheap and go up. We're going to use X or let's use N instead. S looks too much like a 5, right? And it has to be less or equal to 325. So Jessica, if I'm looking at this and I have 1250 times N less or equal to 325, you divide on both sides by 1250. So you use your calculator and divide that out, which means N in this case should be less or equal to
So it's 150 divided by 325 equals 0.0.
no.
Whoa.
No. Did you put 325 in your calculator first?
Oh, sorry, that was
Divided by 1250. That's what this means. Some of you are doing that same thing that you just did. It put the 1250 in first.
Do you want the real answer?
I do want the real answer.
So if 325 divided by
Read it.
Don't
Read
ask.
it. Tell me.
Don't ask. Okay.
Maria, what'd you get?
26.
26. Comes out as a nice even number. Okay?
It was like the entire time.
Okay. So, here is your assignment. I want you, I know I was hoping we'd have more than 10 minutes. Okay?
You failed that one.
I'm trying to shorten it up. Okay? So, this is the 3.2, does it say at the top? 3.7. Oh yes, 3.7. 3.7 at the top. Okay? If you're starting, you're asked to graph these also. I'm going to say let's graph every other one. Okay, so graph the odds only. Yep.
Okay, I just wanted it.
So 3.7, if you want to put C7. Okay. Graph, I'll just put the odds on this part. Same thing here where it says graph the solution. We're going to do the odds. Ooh. You know what? Do we want to do 15 to 20? I don't think we have anything like that. Oh, we are not. That is like pushing you to the next level. We are not doing that. We are doing 1 through 14. And let me look at the last one. Yeah.
But only the odds.
Let's only do and graph all of them and only do 1 to 14. Graph all. Do all, only 1 to 14.
Also,
So we don't need to do the backside.
Correct. Yes. Because when I looked at my test, these are all 2-step equations in 3 steps, and we haven't covered that yet. That's coming in the next unit. So,
I don't want to do it.
okay. Now, I was looking at next week for you, so start on these. 1 through 14 is all you have to do. You guys be able to have that done for Monday?
Monday?
For Monday. Today's Friday. Okay? All right.